I am working as an applied data scientist and research scholar with almost 16 years of experience. And I am very inclined to, learning new technologies. So it is not only the data science. Data science is not the only domain I am working in. I am working as actually a digital transformation lead, and which includes lots of other pillars also, like blockchain, then RPA, and also AR, VR, metaverse. I am also a doctoral researcher, and I'm researching on smart cities risk management. So my research area includes AI, IoT, and blockchain. So the convergence of all three technologies. I have written also the couple of white papers before, and which have been, widely and highly acclaimed. My hobbies include traveling and trekking, and also off-road biking. So I will just go, little bit fast on this because we will be giving some more time on the Jupyter notebook. So let's start. I will be just giving some overview on the approach and the concept of EDA, and then we will be starting with the notebook analysis. So EDA basically is an approach to analyze and understand data that is focused on finding patterns, relationship in the data, rather than on testing hypotheses and making prediction. It is also visualizing the data, looking for trends, patterns, and anomalies, as well as summarizing the main characteristic of data. So in most of the project in data analysis, we can see that it is a major step to clean the data, to prepare the data basically. So once we get the raw data, we need to clean the data, analyze the data, see the necessary patterns which is there in the data. And I think most of the data analysis project are just solved doing the EDA. So we can only have some recommendation after the EDA is getting done, like properly. If it is done, we can have some recommendations after that on the data itself, like we can understand the pattern. So it is mostly, we say that it contains like 35 to 40% of the project time, like any analytical project time in EDA only. So EDA holds a major time, and where we actually clean the raw data, or we transform the raw data into useful data which can be used for the model training. So some important aspects of EDA is like analyzing the raw data. So what are the numerical data points? What are the categorical data points or variables, we can say? Then is there any missing values, so that we need to treat the missing values properly. Like there are some concepts of treating missing values. Of course, we need to see the outliers. So the outliers are basically the data which doesn't fall in the the normal distribution pattern. So it falls actually beyond that. So those data we identify as outliers. Then the visualization of the data, like we need to see the pattern of the data, how data is flowing, or sometimes just seeing the visualization we understand that how different variables are correlated. And so this is also the part of data cleaning, is also the part of EDA. So we need to clean the raw data and prepare the clean data for our machine learning model. So that is one aspect. So as I have already told, we need to handle missing values, and there are some statistical concepts we need to see for that, like mean, median, mode. So I will be, explaining these things in a better way. So let me go to the next slide. So these are basically, the clean steps, we can say, the white steps, the high level steps of EDA. So if you see from the data sourcing part, so data sourcing, see, it can be like if mostly the client is having their own data. So enough data is there with the client side. So mostly you will be getting data from the client itself. If the data is not available, then sometimes we need to go to the public domain, and we need to go and scrape the data from the public domain. So there also the data sourcing part, lots of web scraping techniques come into picture. So today our topic is not web scraping, so I'm not going to the detail of it. So after we get the data, we need to clean the data. We need to see the data, like how is the data, the very different variables, which are the columns which will be very important to us for our or analyzing the data better, and which there may be some redundant columns also which we won't be requiring at all. So those things we need to see the pattern of the data, so that these data cleaning steps actually tells all. Okay. Then we need to see that what are the categorical variables or the data points in our categorical feature analysis, basically in our data set. Then what are the numerical feature? So sometimes it may happen that categorical data is represented in the numerical way, but it is actually not the numerical data. So all these examples I will give you, but very quickly I will give you. So on the categorical feature analysis, we do three kinds of analysis, like univariate analysis, which is like, like analyzing taking only one variable, bivariate when we see the relationship between two variables, and multivariate, of course, more than two. Similarly, we do some, like correlation mapping of the numerical features. Like we can see that how both the variables are related. So we can see the correlation trends and all, like the scatter plots and all. Even the trends and the distribution, we can check for the numerical feature. There can be some derived metrics as well. So derived metrics are actually when you derive some of the data points from your existing data set. So let me give an example. The perfect example can be profit. So if your sales data and production cost data is given, then maybe you can derive another column called profit, and you can just subtract the production cost from the sales and get the profit value. So that is one of the derived metrics. Okay, so I will just go a little bit fast on this. Now this is very important. These I'm actually repeating from my next session. So this is very important, like how we can handle the missing values. So definitely we need to treat missing values, but there are ways of treating missing values. So one option is simply to delete the rows or columns with missing value. And we can do this if large proportion of data is missing. So suppose for an example, if more than 70% of the data in a column is missing. So I don't think that column will be useful for, like doing EDA, because most of the data is missing. So we can go safely and drop that column. Okay, analysis and analysis is very important, and we can derive from somewhere the data. But when it doesn't happen, like more than 70% data missing means maybe this column is not so much important. So this is one aspect. Then imputation. So we need to impute missing values. So for imputing missing values, there are some ways to do that. So either we can impute it by mean if it is a numerical variable, or median, or mode, but depending on the data distribution. So generally we don't get data like asymmetry data fully. Like if we draw a normal distribution and see, it won't be like symmetrical on both the sides. So mostly the data is skewed. So mostly it is imputed with median. And sometimes, like for the categorical data, we can impute with mode, but again, that is very, like decision-taking thing, like you need to take the decision on that. Because say, for an example, if the profession is given, like doctors, laborers, engineers, like that, if the categorical values are given. So definitely, if majority of the data is missing, or say even 30% of the data is missing there in the profession, it is not advisable, because the mode of the data is doctor. We cannot replace everything with doctor, because that won't be the real scenario. So in that case, we won't be like imputing with mode. Maybe we will impute those missing values with the unknown variable. I will be taking questions later. So I will be taking all of your questions later. So don't worry. Okay, so these are some of the ways of like imputation. Even like we can do some algorithm, like through machine learning algorithms also we can impute the missing values. Okay, now there is a third important technique, and please remember this one, because this one I am going to use in my EDA today. So this is interpolation. So in some cases it can happen that seeing some other columns, you can derive the missing values from for the different columns. So let me give an example. So let's say for this loan data set only, the amount credited and the amount of the good, like the price of the good. So since mostly what it happens is that these two variables are highly correlated. The price of the good is very highly correlated with the amount credited, because mostly it happens that we try to take the loan of the exact amount what we are going to buy. Maybe it is a house or a car or anything which we are buying for our home. Okay. So these two variables are very highly correlated. So if one variable is missing here, like if say I want to impute the missing values in good price, then I can impute it from the other column, that is the amount credited. I think it will be safe to do that, because mostly it happens that if the correlation is very high, then we can take the amount credited value in the good price. So in that way also we can impute the missing values. And another part is extrapolation. Another concept is extrapolation, but this is not very commonly used until and unless you are very sure about the data, because this is kind of, like seeing the pattern of the data. You are, like extrapolating, and you are putting the same pattern again in the missing data set. So that is a little bit risky until and unless you are very knowledgeable that what you are doing now on that. Okay, so let me go to the next slide. Okay, so similarly with the outliers, so when we are treating outliers, it is, like it is very important to know different concepts, like how we can treat the outliers. Okay, so some outliers, it may happen like it is a result of data entry error. So if we know that the source mistake, like where that mistake has happened and how that happened, then it can be corrected. So in that way, outliers can be corrected. Okay, in the EDA, we can ignore the outliers because EDA is, like just analyzing the data set from that perspective, that how is the data distribution, what is the like how is the pattern of the data. Then if you're drawing some recommendation from the data or some indication from the data, so if the outliers are there, sometimes we just ignore it, telling that, okay, this particular variable has some outliers. Okay, so that is fine. We can trim the outliers. So sometimes we can trim the outliers with the threshold value. So this part also remember, because I will be showing this in our EDA today. So if there are some threshold values you want to put, and anything beyond that you want to, like just put that cap, so you can cap that way. You can trim the outliers. Transform the data. So some outliers may be the result of the scale of the data. So it may happen that your data is actually, like coming in different scales, like say inch and centimeter. So in that way also you can convert it to a same scale, then the outlier will be, I think it will be reduced. So that way also you can treat the outliers. Then input the outliers. Otherwise you can input the outliers with a missing, like you are imputing the missing values, like with a statistical measure like median. Okay, so that way also you can treat the outliers. Okay, so now I will be giving little bit brief about like how you can analyze the data. So doing data analysis, this is a very important part where you need to understand the data well. So whether your data is qualitative or quantitative. So quantitative is just a numerical data, and qualitative is your categorical, nominal, ordinal. This kind of data is treated as categorical. Then quantitative can be both two ways, that is discrete and continuous. So discrete data is basically the data which is not containing any decimal, you can say. So in the layman term, you can say like number of people, like available in the meeting room. So it cannot be a decimal point. Okay, number of birth in a day or in the city. So it cannot be a decimal point. Okay, so it is a whole number. So that way you can say discrete. And continuous is that which is a continuous data. That means it can contain some decimal values. Okay, and with this there are two more important things, which is interval and ratio. So I will go to it one by one. So interval scale means when actually it can start from a negative value. So say temperature, you can say temperature -30 to -20, and again -20 to 10, -10, then -10 to 0, and then 0 to 10 again. So like that you can give some interval. Its true starting point is not essentially 0. So that is the interval scale data. And ratio scale data is when your true starting point is 0. That means it can never go negative. Like the age of a person, it can never go negative, correct? Like the salary of a person, it can never go negative. So this kind of data can be your ratio data. Okay, nominal and ordinal already I have told you. Now sometimes it happens that nominal data is given as a numerical way, like say male and female is given as 0 and 1, some numerical values. But we need to understand that it is essentially not a numerical data. Basically it is a nominal data, because it is giving you a category, basically the category segregation. So that way you have to understand. Even for the ordinal data also, ordinal data tells you the position. So suppose if I give you example like the feedback of the in a survey. So it is like very low, and then it is fair, and then good, very good. So if I say this, so definitely low is in a better position than very low. And I can actually, like fully replace low, very low, good, very good with in the points. Like I can give, like 1 for very low, and then 2 for low, then maybe 3 for fair, and 4 for good, and 5 for very good. So likewise also I can give, but that doesn't essentially mean that it is a numerical data. I am just representing it in a numerical scale. Okay, so let's try to see this. So what is my age? So age is basically ratio continuous. That means ratio means it will start from 0. That means it has a true 0 starting point. It cannot go negative. Continuous, it can be like, like sometimes we'll tell age in a, like with months also, like 10 years, 6 months. So in that way, it is continuous. Weight can be ratio continuous. Disease can be whether Y or no, N, like yes or no. It can be nominal or categorical. Sex again nominal, country nominal, hair color nominal, income ratio continuous. That means income also starts from 0. It cannot go negative, and it can be in decimal value. Number of people in meeting room, it is discrete ratio. So it can start 0, like no people present, and it can never go to decimal. So it can be anything like a whole number. Okay, number of birth in a day, again ratio discrete, and coffee size, like small, medium, large, it is ordinal. So these are some of the examples of understanding the data. Okay. Apart from this, there can be some identifiers like IDs. So it can be product ID, employee ID, order ID. So these are basically identifiers. These can be numerical or alphanumerical data, and it doesn't have, like much role in our data analysis. So it is just, if we are extracting data from a data set, it may contain some ID. Okay. And ordinal nominal data can be converted to numerical. So already I said that ordinal and nominal data can be represented in a numerical format. Like I have said that male, female can be represented as 0 and 1. Numerical data can be also converted to ordinal and nominal data. How? Suppose say some age group is given, right? Like suppose 10 to 15 years, 10, 11, 12 to 15, and then again 15 to again 20. So we can just, like group them, like 10 to 15, it is teens. Then 15 to maybe 20, the adults, young adults. Like that, we can group the age group. So we are actually grouping it, and we are putting some categories onto it. So that is kind of a representing numerical data, though the age is numerical data, but we are representing it in a nominal format. So I think this is what I need to, like tell some concepts. Then there is something called derived metrics. So I already told you one, that is like the profit we can derive from sales and production cost. Likewise, there are ways of like deriving some of the, like variables which we will be needing for our analysis. So one can be some financial ratios. So given some parameters, you can generate some financial ratios like the credit ratio. Then you can bind, actually, like you can bind, like bean the data, basically group the data. That is what I was telling about this age group. So 10 to 15, you can group it as a say as a children or the teens. So like that, you can bring the data, you can encode the data, you can give some common, like coding factor to the data, like male ki female can be represented as 0, 1, or India, US, you can just represent with some numbers. Okay, some country names you can represent with numbers. So you are encoding the data. And calculated, I told you, like you can calculate from some of the parameters and get your derived metrics. And based on your data understanding also, you can derive sometimes some of the metrics. Okay, so I will be going to my notebook. Let me open my notebook. Okay, so today there are two datasets basically. One is a new application, the credit loan application, and another one is a previous application dataset. So I will be analyzing both the datasets. I will be going very quickly, and this is already some like EDA done before, so I'm just explaining everything in this notebook. Okay, so I think the pandas and numpy, I know like minimum knowledge of pandas and numpy and this matplotlib, the seaborn libraries is required to do the EDA. So that is, you can see some YouTube tutorials or the official documentation. These libraries are very easy to learn. And again, Python is a very easy language to learn. Okay, so now I will load both these datasets. So this is my one dataset, that is credit.csv. And this is a new application dataset basically. And this is another dataset, that is previous.csv. Don't worry about the dataset and this EDA notebook. I will be already sharing the GitHub link with the panelists, so they can share in the YouTube link with you all. So nothing to worry about this. Okay, so just understand the concept. Okay, so how things are done. So these two datasets I have loaded in two different variables or data frames. Okay, so one is new credit, another is previous credit. Fine. So I will just go one by one, and I will go on like analyzing the data. So first I have seen the head, like, like the first 2 rows of the data, new credit data. So I can see all these parameters. See, I told you like there is some ID kind of a variable can be there, and which we don't use in our analysis. So ID, target, and then there is name, contract type, code number, flag on car. So when you get a data set, basically, generally you have a metadata also, like which tells about the, like it is metadata means data about data. So which tells about, like various columns, like what these columns all about. So that from there also you can have an understanding that which columns you will be requiring for your analysis, for determining your target, or which you don't need. So from there you can like select some selective columns and do your analysis. So that depends on exactly the type of data set you are using. Okay. So let me just go ahead. So I am just checking the shape of the data. Shape of the data means you need to check that what are the number of rows and columns. So if you see that I am just taking the first application, that is a new application data set, and I am seeing that these many rows are there and these many columns are there. And it is pretty like large data set, like 3 lakhs kind of rows are there and 122 columns are there. So it is a large data set. Now I am checking that what are the column names. So here also you can check, but it is actually going, like out of the space. So I am just checking once again, like what are the different column names. So trying to analyze like what are the column names I can directly copy from here for my coding. Okay. Then I am just checking that info. Okay. So info means like what is this kind of data? It basically tells you the data type and whether, like any missing values or anything is there. So if you see here, like it is showing you the data type like integer, then target is also integer, then mostly these are object, then again count children is integer. So like this, it is describing the data, like what variable type it is. Then again, I am describing it. So if you see, it is giving me count, mean, standard deviation, minimum, maximum, then 25th percentile, median, then 75th percentile. So all this quartile 1, quartile 2, 3, quartile 2, quartile 3, it is giving me. Okay. So like that, you can check like for the numerical data, like, like what is a max, mean, and median. So these things you can check in describe. Okay. So doing the describe, you can analyze that. Okay. Now so likewise, I am inspecting my previous data set also. So previous data set also, I am seeing the first 2 rows. So this is how like you can put dot head. If you just put dot head without putting any numbers here, it will give you first 5 rows. So I have put 2. So that is essentially giving me first 2 rows. Even you can check with tail also. That dot tail means it will give you last 2 rows or last 5 rows. Okay. So this data set also I am checking. Okay. Again, I have checked the tail also. So all kinds of like, like just to, like to get aware of the syntaxes. Okay. So tail is giving you the last 2 rows. So basically you can understand from like whether it is last 2 rows or not from the IDs. So see, this is starting 0, 1, and this is, like the last indexes basically. Okay. Then I am checking the columns. So same thing I am doing. Okay. Then checking the info again. See, this is also like what are the not null counts are there. So how you will understand that whether there is null values or not, you can understand from here. So if you go here, you can see that, like, have I checked the shape also? Okay, if I haven't, I am just checking the shape. So you can see the rows are like 1670214 rows are there, like 16 lakhs rows are there. Now, if you see how many not null values are there, from there you can understand whether there is null values or not. So if you see here, definitely there are some null values in these columns. So you can say it is not total number of rows which is reflecting. Okay, it is showing that these many values are not null. Okay, so it is like truly like identifiable from here only. Okay, and then you are describing the data again. You are seeing that seeing this description on the numerical columns. So that is, it will give you count, mean, all these things, statistical measures basically. Okay, now now I am seeing that what is a sum of my. So I will be now analyzing the first application now, that is a new application. Then I will be analyzing my previous application. Okay, and then I will merge both and then I will do some analysis. So first I will see that what are the, like kind of null values there. So I am seeing these many columns have null values. So if I just go and scroll down, you will see that these many columns, like till I think days last phone change, till here the null values are there. Okay, so now I am checking what is the percentage of null values, because it will give me a idea like which columns has higher percentage of null values. As I said that I can drop also like if it is more than 50% or 70% based on my decision making. So, and even based on the data set. So if you have the metadata with you and you know this column is not very useful and it is having so many null values also. So based on that decision, you can drop drop those columns. Okay. So now I'm seeing here that if you see, I have taken the percentage, and these syntaxes are very simple. Basically, I have taken dot sum and then I have divided with by row. So shape of 0 means you are taking the first index, the first value. So shape gives actually two values, that is rows and columns. So in this case, you are taking the first value, that is the rows. So you are dividing with total number of rows. So it gives you a percentage, and you are multiplying it 100 and you are rounding it to 2 places of decimal. So syntax is very simple. Syntax you can copy also, you can get in Google also, in the official documentation also you will get. So there I am getting the percentages. So you can see that all these columns are having very high percentage of missing values, like 69.87, and it goes up to, like these are the percentage which it is showing me. Okay, so now based on this I can take some decision. Okay, maybe I have the metadata present with me, so seeing on those things also I know like these are the columns which are not be very much essential for me for my analysis. And also the because most of the data in these columns are missing, like about 70% of this is missing value. So I take a decision on that. What I have done is I have dropped like whatever is above 45% missing value any column is having, I have dropped. Now again, there is no hard and fast rule on this part. Okay, so it is solely your decision making. You need to check data, you need to check the columns. Sometimes we just drop more than 70%, 60% based on the data set. You have to take this decision. You can make it as 50% also, like more than 50%, whatever is there you are dropping. Okay, so there is no science behind it to understand. You need to understand the data first. Okay, so I have dropped here that more than 45%, whatever the mean value is there, those columns just drop it. Okay, so this is a syntax for it and it is very clear. So I have just used a log function to take all the rows and only those columns whose mean is less than 45. So that is what I have done, 0.45. Okay, so I have written only those columns and those that much data set I have written. Okay, so now I am checking the shape again. So I am checking the shape and it is giving me, yes, some columns are dropped. So you can see that before it was 122 columns. Now I think some of the columns have dropped. So it is giving me 73 columns. Okay, fine. So now I will go and check some other columns. So these are my columns basically, which I am checking that what are the columns available now. Okay, so you can analyze like this, or you can, for your, like if you want to analyze on certain column, you can just copy the column name from here. Okay, now again I am checking what is my null value now null value content. Okay, so now it is very essential to understand this. Now see, I am seeing that occupation type has some null values, that is 31.35%, and these values I won't be dropping, I will be imputing with something. Okay, that I don't know what we will be imputing now, but I have to treat it basically. So now these are the sum of the values which is less than whatever I have dropped, and this is now what is remaining. Okay, so now I will be checking the first one, occupation type. Okay, and I am checking that what are the values there. So it is a categorical feature. That is one thing I am seeing, that some of the profession is coming, like laborers, post staff, accountants. Okay, I can check the value counts also, like what is exactly the value counts of the laborers is 55,000. So likewise, all the value counts are coming. Okay, so now see, as I told you that you can impute with mean, median, and mode, and it's a categorical value also. So it is highly, someone will say that why not to impute with mode. So let's see what is the number of missing values here. Okay, already we have seen that some kind of 31%. So what 31% means is that 96,000 rows are missing. So definitely 96,000 rows, when the number of rows is that much high, it won't be advisable to impute with laborers, because that is a mode here, that is having the highest value count. So laborers you can see is highest value count, but that doesn't mean that all 95,000 data will be laborers only, correct? So that doesn't make the sense. So in that case, we can impute with something unknown also. So we can say that occupation missing or unknown type of occupation. We can impute the data with that just to, like drop the null values or replace the null values. Okay, so that is what I have done here. I have imputed it with the unknown variable or unknown value. So everything is which is nan. So here I have used a numpy function numpy np.nan. So everything which is np.nan I am replacing with unknown, and in place equal to true means it will again save into the data set. So you don't have to assign again to the data set. It will just save into the data set. Okay, so I am replacing occupation type with unknown. Now if you see what is the sum of the null values, it is 0. Okay, so this is how, like these are some of the important things. Now I will go to the other things. Okay, so now you see the value counts I have taken. So you can see the unknown is a maximum. So it was actually the maximum data. 31% was missing, and the value was around 96,000. So it is all replaced with unknown now. Okay, now let's go to the some other features. Okay, so now again I am checking that what are the like values which are null. So now I am checking the next highest is the exterior source, external source 3. Okay, now what is this data all about, or what is this variable all about? Okay, so let's see. Okay, so before doing that, there are some other columns also which are not required. So I had the metadata present, so I knew that these are some of the columns which will be not very much useful for my data analysis. So I have just like dropped those columns because I will not be using these columns for my analysis. So if you have a data set where you have some redundant columns and which you won't be using it for your analysis, you can shorten your data set. So you can just drop those columns. Okay, so I have just dropped these columns. Okay, and then I'm seeing the shape. Okay, so the shape you can see the column number is reduced furthermore. Okay, so now I am checking again. So this is again the highest null which is present. Now let's see what is this value about. Okay, so this is occupation type. Okay, that is fine. Okay, exterior source, external source 3. Okay, and external source 2. Both I have plotted together. So if you see here, let me go to this again. So some of the missing values are here, external source 3 also and external source 2 also. So, but the percentage is low here, but though the missing values are there. Okay, so I am just seeing both these columns together, source 2, source 3 and source 2. Okay, so let's go. Okay, so I have drawn a box plot and a box plot basically. Okay, so this box plot and another plot was there. Yes, a distribution graph also I have plotted. Okay, so it has come like this. Let me just click on this. Okay, so I am just analyzing that whether there is any outliers in this column. No outliers are there. And if you see, the data is slightly skewed for both the variables, even the source 2 and source 3. So if the tail is, like the left tail is little bit longer. So I can say that the skewness is there. So we can impute with the median. Why I am checking the outliers also because, like to see that sometimes if the data is fully symmetric, we can replace or impute with mean also. But if the outliers are present, if median is like slightly affected by outliers, but mean is fully affected by outliers. Because let me give you an example why. Suppose I am taking the salary of 10 developers, and which is coming around 1 lakh. Okay, 1 lakh per month. So with 5 years of experience, they are getting 1 lakh per month. But if I am seeing that with that a value is there which is very, very high, that is like kind of 3 lakhs per month. So maybe that developer has extraordinary skills, or he might be working in some very good company. Okay, some very good company. So his salary is very high, but that will actually affect your mean. So if you have taken 10 data points, it will affect your mean. That your mean will be shifted towards the right, that is the higher side. So that is the reason that I am checking the outliers first, and then I am checking whether the data is skewed. So that decision making will be very easier for me. Okay. So here I am checking that okay, it is slightly skewed, and so I am just replacing with median. So you can see I have taken both the columns together. So exterior source 2, exterior source 3, and see these things. There are ways of doing it. Okay, so different people will do it in different way. you can write a common function and just, like map it, like put the apply or the lambda parameter and to map to the function. If you have, like several columns and you are treating it with median, so different people will do it differently. Since I have only 2 columns, so I have just put in a for loop. Okay, and I have put in a for loop, and I have just replaced the values with median. Okay. So now let me check the another one. Okay, so now this part is going to be very important. Now I told about the interpolation, because looking at the other variables or the data points, when you try to impute the value in some other data like variables, okay? So that is called interpolation. So when you are finding a relation between them. So now if you see another missing value, high missing value was in amount good price. Okay, so if I go up again, you can see the next one is amount good price. Okay, so here also some missing values are there, though the percentage is very low, but the missing values are there. Okay, so now this one is this exterior source or external source 3 is treated. Source 2 is also treated. So I am checking on this part, amount good price. Okay, so I am going one by one, and I will be, like going for all the missing values. So let me see this one. So if you see, so generally what happens, I told you, right? Since I have the metadata and I am understanding that this relationship can be very high, that what is a good price you are going to buy, the loan taking on it or the credit applied for it will be also similar. So if your good price is 10,000 INR, definitely your loan amount will be more or less near to that. Maybe you have just done some down payment 1,000 rupees and you are asking for now 9,000. Or it may happen that you have shown the price more and you are asking for 11,000. So whatever may be the reason, your loan amount will be more or less equal to your good price. Okay, so that is the kind of interpretation you can do. To like validate that interpretation, you can plot a scatter plot to see the relationship, because both are numerical variables. So that is what I am doing here. I am plotting a scatter plot over here, and I am seeing, yes, exactly, there is a very high positive correlation between them. Okay, so that means if my loan amount or the price of good is increasing, an equivalent will be my loan amount. Maybe more or less like little bit here and there it will be there, but it will be safe to impute my price of good missing values with the respective loan amount credited. Okay, so that is the one important interpolation method. Okay, so that is how I have interfered here also. I have put the inference here, and that is how I have imputed the missing value of the amount good price. So I have just put a numpy where function query. So wherever it is null, okay, wherever it is null is equal to true, take the amount credit value, the respective amount credit value, otherwise return the amount good price. So if it is not null, return the amount good price. So that is a simple syntax. So that is how I have treat the good price. Okay, so this is one example of interpolation also. Okay, now again I am checking that what is the sum of my missing values. Okay, it is 0. Now it is treated. Okay, so on various, like steps, I am checking each and everything over here. Now I have plotted a pie plot and checking my next missing value column, that is a name type suit. And I am seeing that what are the variables or what are the categories present here. So if you see that this is kind of like telling about the people who have applied for the loan, whether they are unaccompanied or they have family, spouse, partner, like they are accompanied with spouse, partner, or children, like anybody who has accompanied them in taking the loan. Okay, so you can say as a co-borrower. So those data is present here. This is again a categorical data. So I am just taking the amount of data which is like present in the data set. Okay, so now you see that the highest one is this one, unaccompanied, 81.2%. Okay, so this value is really high. Okay, now again that thing comes that whether you want to, like, and what is the missing value percentage? 42%. Okay, so whether you can impute with mode. Okay, sorry, not 42%, 0.42%. Sorry, very sorry. So whether you can input with mode, since the number of rows is very low, we have 3 lakhs data and some around 1,200 data is is null. So okay, it is okay to replace with unaccompanied, because unaccompanied is a mode here. At 81.2% data is unaccompanied. So I have just replaced with mode. Okay, so because the data is very low and it doesn't make any significant difference. if you're replacing with mode. So likewise, you need to understand the data and you need to take necessary actions. Okay, now let me check the null values again. Okay, so now I am checking the null values again. Okay, most of the null values are treated, but previously I was taking with 2 places of decimal, but now I have put 4 places of decimal. I am checking whether anything is left out. Okay, so now I am saying that is amount, annuity, count of the family members, and the day's last phone change. These are some of the things which is left out. Okay, this is a very big data set actually, and a very big idea. It takes some little bit time, but I'm going seriously sorry for it, apologizing, because 1 hour I need to complete. I'm going little bit fast. Okay, so now whatever numerical columns are there, without seeing anything, because the values are very small, as you can see 0.0039%, or 0.0039 basically. So I am just replacing with median. So I'm not analyzing so much about it. Some missing values are still there, so I'm just replacing with median. Okay, so now my all these missing values are treated. So if you see here, everything is 0 now. It is looking good. All the missing values are treated. Okay, so and you can see that the complete row numbers are showing as not null, not null, not null. So now there is no missing values. Okay, so now changing the days column and count columns to the integer. Now, if you see in this data set, some of these columns which are integer, which should be integer actually or int type, it is given as an object type. Okay, so I have identified some of the columns here which are given as an object type. Okay, or float type, I don't know. Like, let me check which other things I have changed. So count family members is one. Okay, so let's see, count family members. Count family members. Okay, count family members, it is given as float. So basically count cannot be of the family members, can never be a decimal value, right? It's a discrete value. So again, you need to understand data over here. Okay, so I have changed it to integer. Likewise, there are some data points which are in float and which cannot be in decimals. So continuous, it is kind of a discrete value, the whole numbers. Like days registration, days last phone change, this cannot be the decimal values, float value. So all these values I have changed it to integer. So this is a syntax for it, like you can put AS type. So it changes to the different data type. Okay, now again I am checking. Okay, so this is okay. So now listing all the object type columns and confirming the values to be in string type. Okay. Okay, so what are the values which can be in the string? So that I am identifying over here. Okay, so everything which is in object, I am just converting it to the string. So that is what I have done here. So I have listed first everything which is in object and I have converted it to the string data type. Okay, so for ease of analysis, I have done it. Again, it's like optional step, you can do it. Okay, then I am checking the information. Okay, then some other like parameters I am checking, like the gender, how it is given. So you can see the value counts is female is more than the male is less. So the number of females are more in this loan application data set, and some are which is unknown, like 4. But I have kept it like that. I haven't changed it. If you want, you can change it with the mode. That is okay, because only 4 numbers are there, so you can replace it. But I have just kept it like that. Okay, so this is our like I have just plotted it, and this is how it is showing. So this is a male, female, then this is a XNA. Okay, so like this it is I have plotted against the target. Okay, now let's see some other values, variables, that is organization type. Okay, now this is one more important categorical value. So if you see, I am saying here what are the organization type which is there. Now if you see business entity type 3, then that is something unknown, self-employed, other, medicine. So these are some of the occupation type. Then type 2, type 1. So many subcategories are present in this data. So you can actually, like for your ease of analysis, you can change whatever containing business, you can change it to business. Like just, like taking this out, this entity type 3, entity type 1, type 2, because this is unnecessarily creating some more, like categories. So I can just safely, like go and just replace this string basically. So let me just do it. So again, I have used a lambda expression here. So whatever value like this, I have, like identified some of the values like industry, trade, transport, business, which has some subcategories. So whatever values you have, like industry, trade, transport, you are just replacing with industry. So you are checking if industry is there in your word. Yes, then return industry only. Otherwise, return whatever was like the original value, that is the industry. Okay. So likewise, you have replaced everything with the category name only, just eliminating the subcategory. Okay. So now how it is looking? So I have just reduced basically the number of categories. So see, it's only business is there, no type 1, type 2, type 3. Then self-employed, and I'm taking some percentage. So business class is showing as a more percentage, 27%. Okay. So you can see that this is the distribution which is showing over here. Okay. So likewise, you can plot some graph and see, but even from the data, it is clear. Okay. So in inferences, people who is in business field applied more in number of loan compared to the other fields. So this is actually, like relevant from the data also. Okay, it is self-explained. Then I am checking some other. So you are doing, like column wise for every variable, you are doing some kind of analysis. So again, I am checking for name contract type. So name contract type is giving you two categories basically, whether it's a cash loan or revolving loan. So again, I am checking the numbers for that. Then flag owned car. Okay, so these are some of the categorical values I am checking. Then whether the person owns a house or a property, realty. So that also you can check the number like no or yes. These are all categorical, like values I am checking. You can plot some graph also and check, but that is what I am analyzing over here. Like what is the number of these people? Okay, and then I won't be like spending much more time on this categorical thing like what I am seeing over here. I will be going little bit more important thing because time is very less. So yes, so these are some of the times you can see that some of the days of like days birth, days employed, everything is given in minus. So if you see that what are the unique values, you can see that it is giving an array or the list of minus variables. Why minus? Now this is very interesting. Minus means they have a like special way of recording this data. So from today, how many days minus before like the person has born? So something like that. So okay, so that is a number of days, like how many days before the person, like 94,061 days before the person has born. So minus like today minus this. Okay, so this is why all the days data are in minus, negative. Okay, so we can do one thing. We can first take the absolute of all the data. So whatever is minus, that will be like changed to positive plus. Then what you can do, you can change it to years to have a better like view. So you can actually like divide it by 365. Okay, so this is the way you can do it. So I have done it also. See that for the days employed, I have done like dividing by 365, and I'm checking the years. So still it is minus because I haven't done the absolute over here. Okay, so you can see that minus 49 years, minus 47 years, and what is the count? 4. So minus 49 years, 4. Okay, so likewise I have checked others also. So here, see, I have changed everything to absolute. So whatever variables I have seen, like days birth, days employed, days registration, ID published, last phone change, everything I'm changing to absolute because these all are given in negative values. Okay, so I'm changing it to positive. So now I'm just testing one of it and it is okay, it is positive. Okay, now you can go ahead and actually, like check the outliers, okay, in this data set, or you can actually change it to the number of years as I have shown it here, okay, by dividing it by 365. Okay, now I am I want to do some binning on this data. Okay, so that is what amount income, and if the amount income total is given, and I am trying to see what is the quantile of this data. Like I have put various quantile parameters like 0.1 quantile, 0.15, then 0.2, 0.25. So if all this quantile data I am seeing, okay. So then actually I can get a derived matrix also. So here I have got a derived matrix. So I am binning everything on a very, like in a group, like very low income group, medium group, high group, very high group. So this example I have told you. So this is a way of, like getting a derived matrix. So here my derived matrix is income slab. And I have just, like done a quantile cut on this data set. And I have cut the data into or bin the data in these quantiles. Okay. And I have put the levels as very low, low, medium, high, very high. So this is what I have done. So now I can see this income slab. So low is the maximum number. So in the low data set, and in the medium, it is this number. So likewise, I have done some categorization, okay, on this data. Okay, so this is for my analysis, like how many numbers are there in the low income data set or in the very high income data set. Okay, so again, you can be in the date of birth also, like the age. Okay, so you have the age factor, and you can see like what is your minimum age and maximum age present in your data set. So that is what I have seen here. So my maximum age is 69 and minimum age is 20. So I am just beaning it on the, maybe on a, like giving a width of 5 or 10, whatever it suits you, that is fine. So this I have, for this I have put a NP arrange function, which is nothing but you are giving the lower parameter, the lower value, that is it is starting from 20, then 71 means it is excluding 70, means that is it will take 70 till 70, because see my maximum value is 69, so I have put 70 because I am putting it in the multiples of 5, so that it is, you know, like easily divided in the like in the width of 5 groups. Okay, so likewise it has binned me in these sections, like so sorry, class width of 5. So 35 to 40, 40 to 45. Likewise, it has binned me the age group. Okay, so I have, again, this is a derived matrix. So I am putting the age bins and I am seeing that what are the numbers, you know, like like falling in this category, like 35 to 40 years of age. Okay, I want to ask the panelists, do we have some time or we want to continue it later, because this is little bit a bigger EDA and it cannot be completed in 1 hour.
Ma'am, actually, we are now running out of time. So if it can
Yes.
be covered in 10 to 15 minutes, then that's it. That's okay. But I think if it's more than that we can plan the second session on that.
Okay, so I will be taking 10 minutes more to see, like, you know, like some of the important things, to like just highlighting some of the important things.
Okay,
That
okay,
will be
ma'am.
okay.
Then we have to take the Q&A also. So we have few questions in the Q&A.
Okay. So what do you suggest then? Shall I take the Q&A and take the second session on this?
No, I think, ma'am, you should complete the session first. We can see that Q&A, how Q&A consists of, how what type of questions are asked. I think it can be covered in the session, during the session only.
Okay, so I will be just, you know, like going through it very quickly. Yeah, I will be sharing these data sets so you can see these also. So most of the important parameters I have already, you know, like captured. So I'm just going to it very, like the important factors only I will be covering now. Okay, so now see, I am checking this amount quantile thing and amount income total. So here I actually, if I plot a box plot here, somewhere here, and okay, so what is there is that now since I have seen that this, you know, like amount quantile, the maximum values are coming very high. Okay, so I told you, right, for handling outliers we can cap the maximum value. So since I am seeing that most of the data is present, you know, like beyond this value actually, so it is kind of 10 lakhs, the amount income total, like, you know, like some outliers are there, so more than 10 lakhs, but most of the data set is less than that. So I am just capping it. So that is one way of, you know, like handling outliers. I will show you in the box plot later. So I am just capping this data. Okay, and then I am seeing the value counts basically. So this, still you can see that this is a value count which is given, like this value like that. This is the amount income total, okay, around kind of 1,35,000, and then this value is like the count is 35750. Okay, then the max is this much. Okay, so around 10 lakhs kind of. Okay, 10 lakhs. Now I am trying to plot a box plot over here. Okay, so now I am treating the outliers basically. Okay, so you can see that there are some outliers present. Even after capping also, there are some outliers present. Okay, so it is fine. I will leave it as it is now, because already I have capped some data in like some of the, you know, like beyond some 10 lakhs data, I have capped it with 10 lakhs only. So whatever is present beyond 10 lakhs, I have capped it with 10 lakhs. But still, you know, like it is taking some outliers. So let's see some of the, you know, like other variables also. Okay, so again, I am checking the shape. Okay, so now I will be telling you that, see, I have written a function over here. So how to check the outliers basically, like when you are treating the outliers, it is very important to know the box plot, basically the box plot concept. So everything, see, you see this middle line, this is a median. Okay, this is a IQR range. So this is basically telling you Q1, so first quartile. This is the third quartile, and this is a IQR range. And this is a right fence and this is a left fence. So this is actually the formula for this. So lower range, it is also called, the left fence is also called the lower range. It is Q1 minus 1.5 into IQR. So IQR is what? It is difference of your Q3 minus Q1, and your lower range will be anything like anything beyond your lower range will be your outlier, and anything beyond your upper range will be again the outlier. So your lower range is calculated as this, like Q1 minus 1.5 into IQR, and this is a formula. This is a statistics formula, okay? And the upper range is Q3 is 1.5 into IQ1, okay? So this is a formula. So this you can derive. So instead of, like writing every time for all the numerical columns like this, you can actually return the upper range and lower range writing a generic function. So that is what I have written over here. Okay, so you can see remove outlier should not be the name. It should be actually get the upper range and lower range. So I have just written a generic function over here, which is returning me both upper range and lower range. So any variable I will be passing here, like I have to pass the data frame and the column name, and it will give me the upper range and lower range, and accordingly I can treat it. So if I have to retain it, I can just retain like whatever is between this upper range and lower range, and I can, like assign to my credit data set. So that is one way, but I won't be removing the outliers like that. So I haven't done that. Maybe I have just imputed with median. So that is here I have this is the line which I have done here. So I have just, like whatever is beyond the upper range here, I have just imputed with median. Okay, so that is how I have treated the outlier. So I am just going to the important concept. So you can see now the outliers have reduced. Okay, so it is being treated basically. So now I'm just going important. So this is one way of treating the outlier. So I am checking for all the columns like this, and I have treated the outliers. Okay, so likewise I have gone. Okay, now let's see that the target variable. Okay, so one is 0 and one is 1. So 0 actually, like tells about the defaulters versus non-defaulters. Okay, so this blue portion is a non-defaulters and this red portion is a defaulter. So that is what is the meaning of this data. Okay, so I will be actually dividing both this data frame into two parts. That is a defaulter, that is a target equal to 0 and target equal to 1. Okay, to have a better identification. Okay, so here I have done some multivariate analysis. Okay, so let's keep this. You can check this EDA actually. Okay, so here it is a part. See, I have splitted the data set into two data frames. That is, one is with the target one, that is one who is defaulters, and one who is non-defaulters. Okay, so likewise, I have done some analysis. So like I just try to figure out that, like how many male defaulters are there, how many female defaulters are there. So likewise, I have plotted some graphs. So if you see this here, the gender thing is given. Okay, so gender based, it is the whether the defaulter is more or non-defaulter is more. So if I just go here, so female was already more in this data set. So if you see here, I think female basically, I think it is almost same, but the male defaulters are more. If you see, the male defaulter is much more. So this is how you can interfere, like put the inference here. Okay. So likewise, I have done some more things like contract type on the defaulter, non-defaulter. So I have just checked that whether my cash loan defaulters are more or revolving defaulters are more. So even like on other parameters, you can check, like if the person owns a car, whether he has defaulted more or not defaulted more. So likewise, you can plot these graphs and see. Even like if the person owns a property or a house, whether he has defaulted more or non-defaulted more. So this is all the kinds of analysis you can do. Okay. So this is a little bit vast. So I am just going into this section. So these things I think I have told you, like on different parameters, you can do this segmented univariate analysis. This is what I have done, like occupation wise, who have defaulted or who has non-defaulted, like checking the numbers. Okay. So this is kind of some kind of inference I am getting over here. Okay. Even like the weekday when the loan is processed. Okay. So I'm not putting much time on this. Okay. So based on the age, okay, so these are these things I have done. Now working on the previous data set. So if you have seen the current data set, similarly, I have checked the previous data set, like what are the parameters there, what are the null values, and I have treated some of them. So if I don't need any columns, so first I have dropped those columns, okay? So those way I have just, like understand how the previous data set is. Then I will go straightforwardly to where I have merged these two data sets. Okay, so again, I am doing some analysis on different columns of the previous data set. Okay, So likewise, I'm analyzing this. So I will go somewhere where I have merged these two data sets. Okay, again, you can understand this very well. It is just, like you are just analyzing various columns in your data set, like how it is coming, and treating the missing values also accordingly if you have to treat some. Okay, so now merging both new and old data frames. So now I have a new data set and I have a old data set. And what will be my merging parameter? That is definitely my ID. I told you that we have a ID parameter, the customer ID. So that is on the both data sets. So we are merging on that. And it is an inner join. Okay. So this is the syntax. So now I have this many columns are there, which is coming. Okay. So now you can actually see, like some of the parameters like the client type, like whether it is a new, refreshed, repeated, unknown, when on the merged data set, basically. Because these are some of the data set which is data which is coming from your previous ones, or whether it's approved, cancelled, reviews, unused offers. So likewise, you can see some correlation. Okay, so you can see this value is like in the dark green. So in the with the color combination, you can understand the different values which is coming over here. Okay, so likewise, you can see some other parameters like name, contract type. So new, refresh, repeated, unknown with the client type. Okay, so you can check also, like, so these are like various things. You are analyzing the data, so you are plotting some bivariate, multivariate analysis on different variables, and you are doing the analysis. Okay, so if you see here percentage of the payment difficulty, so you can see approved and what are these legend, new, refreshed, repeaters, unknown. So you can see the cancelled one, the new are mostly the cancelled ones. Okay, so with the payment difficulties, so that way you can like have some conclusion of the data. Okay, so this is the way like you can merge different data set and you can do some advanced analysis. So this data set is actually like very good data set and very good EDA notebook. You can get most of the syntax and most ways like the data is treated, like all the ways, like all kinds of things I have shown here, try to show here, like the method of interpolation, then how to impute with median. So all these kinds of methods I already explained. How to cap the outliers. So you can like have a reference on this data set. That is a good one. This is a good one. Okay. So likewise, I have done some more analysis. You can see that approved and cancelled, cash loans and revolving loans. So from the legend, you can understand this is cash loan, revolving loans, and then percentage of payment difficulty. So if you see the refused one, okay, and cash loans, the percentage is more, the payment difficulties. So likewise, actually, when you're analyzing on both the data set, that is some of the analysis I have put over here in the plots. So I hope this has given you some insight. You can check this EDA notebook. I think you will be understanding better. So these are some of the plots I have put. You can see some of the categorical analysis I have done, like income slab on the amount credit. Okay, so these are some of the like box plot I have plotted over here to check like how it is, like based on education how it is changing, based on the income how it is changing. Okay, so likewise you can also do this analysis. Okay, and out of this, like all these inferences together, I have put like a final conclusion, whatever I have seen in this data set. So this is what is EDA. I think it has given you some insight, though the time was very short for this kind of a big, like two data sets, merging two data sets, but I have tried to, like cover all the concepts.
So, ma'am, first one is it appropriate to perform one hot
And
encoding
hot
on
on
ordinal
getting
data?
on original data. See, you
Yes,
can
ma'am.
okay, so basically, if you are deriving a column, you can put some encoding. You are not tampering the original data. You are deriving some column on it. So you can do it. Okay. In one to drop rows with mean greater than 45 as your code, or rows with null percent greater than 0.45. So that is the thing I have done here. Null percentage greater than 45% that I have done. Like I have just dropped all those rows. Okay. Greater than 45, no, it is not the number. It is a percentage which is greater than 45% I have dropped. Okay. Will it not be better to leave the business type as it is instead of merging? Example, business 1 to 3 may stand for small, medium, large size. See, again, this kind of decision, it actually, like depends on you. How is it data set? So in my data set, it was very like, like the categories were coming very lengthy. So just try to, like make it short and crispy. I have just, I deleted the subcategories and to see that what are the main kinds of categories present, business, industry, trade. So I wanted to see that. Okay. So again, it is depending on your decision and on your data set. Okay. So there is no hard and fast rule in this. please send the resources to our email address. Okay, I will be sharing it with the panelists and they can share. Okay, I think it is done. Thanks everyone. Have a great day.